All right, folks. Thank you, Luna, for this wonderful, magical musical interlude on the guzheng. Next up, we have our RQT fellow from Australia, Elija Perrier. He's going to showcase his RQT fellowship project, which is about something really important and ambitious, the Handbook of Quantum Governance. Elija.
Thank you. Thanks for the introduction. Hi, everyone. My name is Elija. I'm hello from Sydney. For those that don't know me, I'm a researcher at the Centre for Quantum Software and Information in Sydney. I recently submitted my PhD on quantum ML, but I also have a background in law and economics. And I was kindly made a fellow of RQT, which is a great initiative. And today I'll talk a little bit about the Handbook of Quantum Governance, which is the project I'm slowly but surely proceeding towards. So what is it about? Well, I got into this game of, I suppose, combining quantum and law and other fields a few years ago due to my research in AI ethics. And I sort of felt like now maybe the time to sort of consolidate some of the work in this area and maybe set out a work for people across quantum and other fields which they can refer to advance the field of quantum governance. So the idea is we put together a handbook where different authors contribute. The kind of basis of the handbook is somewhat from a paper I wrote a couple of years ago called the Quantum Governance Stack. The idea there is we have a tech stack, which we know from sort of science and technology, and we want to map governance instruments to that tech stack. Often what happens with quantum is people think, wow, quantum, we need to do something, wow, here's the law, and they just sort of get thrown in together. Whereas I think a more focused approach, for example, understanding where in the technology stack the tech instrument should be applied is key. The handbook hopefully will be a resource for scholars and practitioners in the field, and importantly, it will be prepared via engagement with authors and stakeholders across a range of areas. It's really important for these books to be useful that it's not just people in one section. Why bother? There's always a question one should ask. Why have a handbook of quantum governance? Well, as we've seen today and as we know, quantum information technologies are emerging and they will, if we can reach fault-tolerant quantum computing, have a significant impact. If you took a time machine 1,000 or 2,000 years into the future, if we build a quantum computer, I genuinely think there'll be two things that come out of this century. It'll be quantum and AI, subject to us not killing ourselves. That's why it's important. It's hard to do, but if we do it, it will be huge. All technology, all behaviour subject to governance, and so how we govern new technologies is key. Tech governance is an area which is very old and very well established. So it's critical to be able to then situate quantum governance inside this broader field of tech governance. And you see this, we've heard comments today on, is there anything new about quantum governance? I was just chatting to Glenn out there about, I think part of the answer to that question comes to asking yourself, what is the purpose of governance? And hopefully those who have the time to contribute to the handbook can help answer that question. So let's talk a little bit about the project. So it involves the research and preparation of a handbook of quantum governance. The idea, as many of us know and love from your typical Oxford or Cambridge handbooks into anything, it provides a comprehensive survey and entry point for people into the field. If you drew a Venn diagram of the people here today, it is quite broad and will have, so I think a handbook, it's incumbent on anyone who puts together a handbook to allow different entry points for different levels of expertise. That's part of the purpose of this. So if you're a lawyer and can't add fractions, as I was about 13 years ago, you should be able to read this and have a bit of a précis of quantum. And vice versa, if you're someone who just works in a lab, you should be able to pick this up and understand some of the key issues. Again, and as part of that, it will be pitched at a range of audiences, not just people with PhDs in X, Y, or Z. And I'll go through some of the architecture, and I'm very open to any comments and criticisms, thoughts as well. So yeah, so part of the aim of the handbook, and we've heard this a little bit today, is, often when people talk about risk, they think of downside risk, but risk is really decision-making under uncertainty. And so part of that uncertainty is, will quantum have the upside which is promised? And, the way I think about the world, and I think someone else talked about this as well, is can you frame a problem as an optimization problem? And so for quantum, we want to optimize. We have several objectives. One is to build a quantum computer because we genuinely think we can achieve great things with it. But equally, we have another set of objectives. And so part of what we're trying to do is understanding, how do we compute trade-offs? If you work in AI, this is bread and butter for AI. You may have an objective to do X, but you also have to do Y. And so understanding how you compute trade-offs is critical. If you study economics, this again is fairly basic stuff as well. The aim of the handbook is to assist how would one develop a quantum regulatory ecosystem. We've heard a lot today about the culinary dilemma, which is, do you go hard early or do you wait? But if you wait too long, then norms can be established and sunk costs for changing behaviour can be too high. Sort of see this, anyone who's on their phone all day will see this. So it is a tough question, but we don't want to kill the golden goose by coming in heavy with too much law very early. If you go around to any lab, I was in a lab in Sydney with my colleagues from Sydney a few weeks ago. Their focus is just to get the thing to work, and really they don't have the bandwidth to think about any of this other stuff. But that's why we're here, to do the thinking, and the handbook, I hope, will assist with that. Talking about frameworks, there's a million frameworks for everything, particularly with AI. So one of the interesting things is, hopefully this handbook will give a bit of a mapping of the types of risk and ethical frameworks which may be of use to solving problems that the handbook focuses on. It will talk about, it's hard, we don't have a functioning quantum computer yet, in spite of what some vendors say. One can only draw on comparisons of other types of analogies with, say, how would you practically implement. So the kind of idea here I'm thinking is, there is serious thought here that any quantum computer that would be of any functional use may be embedded inside an AI system, because it is a complex system that's got too many buttons to press for a human to do it. To control the system, you need to wrap it in ML. So therefore, you need to understand how is ML governed and that kind of thing. And then, of course, there will be a section which focuses on domestic policies and international politics. Quantum is difficult. As I think Feynman said, anyone who says they understand quantum doesn't really understand it. Part of the handbook will have a detailed exegesis of the technical aspects of quantum. There is a lot of great stuff out there, as we've heard earlier, but it'll really be focused on what do you need to know and care about when you're considering issues to do with governance in quantum. It'll look at some of the theory, not too much, and the different areas of quantum information technology. I have a bias towards quantum computing myself. It'll be looking at issues, some of the challenges, error correction, so on and so forth, fault tolerance. So for people that maybe don't know what that is, that's we need the computer to be able to have error rates which are very low as we build a larger quantum computer. One thing so my day job for my sins is I'm an investment banker in Australia, and one of the things we're often focused on in banks is risk. And one of the things you will probably find if you study AI and risk is, although there's people talk a big game about Gen AI and risk, actually when you go to the actuaries and the people that control risk inside institutions, they're very loath to implement anything that they don't really understand. Understanding then how a black box technology, because this is what it will be for most people, would be integrated into existing risk frameworks of companies and governments is key. We're not going to reinvent the wheel because we've built a quantum computer. So really understand how to join the dots between how quantum computers function, what they can do and what their risks are, and how we deal with the risks is key. So there's a lot of work to be done there if you're looking to write papers and further your academic career. So I hope that the handbook will be of use. I'm going to canter through in the next 6 minutes some of the structure. As you'd expect, there's an introduction, just talking about the fact that we are in the era of quantum technology. Talking, again, high level about sort of opportunities and risks. What is quantum governance? It's always good to start with that question. As I flagged, we'll talk about some of the technical foundations of quantum. So really, again, what do you need to know if you're concerned about governance? You don't need to know about abstract Lie groups, but you may need to know about sort of other kind of issues. Then I'll be again, this is not all me, I'll be asking for people in this room and others to contribute. We want to describe what is the technology stack of quantum, and what are the different sectors, what might quantum computers look like in, say, 5, 10, 50 years' time, error correction and fault tolerance. Key thing is how you can control quantum systems. And this kind of comes into this third chapter, I suppose, which is what is different, well, sui generis, as we like to say in the law, about quantum. It all depends on where in the technology stack you are. If you're just looking at the outputs of a quantum computer, as was said by one of the people up here earlier, you're essentially just using measurement statistics that arise as you run an experiment. That is classical data. But if your claim on governance is to how the computation unfolds, which is so if you do fair ML and you're concerned that you don't want your chatbot to do something bad, oftentimes the claim is that the computation must unfold in a particular way. If that's your claim, then how computations unfold on a quantum computer is different, and how you control that is different. So that's maybe one reason why you may think that we need some different forms of quantum governance. You may not care about that, in which case we don't. How effective could it be? How can we adapt existing systems? We're talking about the governance stack, so I just like to think of governance in law as you think about a tech stack. So who are the actors? What are the instruments that they use? How could that be used to create a regulatory ecosystem that deliberately promotes the development of quantum computing? What are the challenges in this? Again, the way you control systems is different. You can't control them in the same way, per se, as classical systems. You can't copy data on a quantum computer, for example. Skipping quickly through, there's a section on who's involved here. So how should we think about who's involved in quantum? I like to think about it sort of from the top up. You have states, public institutions. We heard about a proposal for an FDA, private companies, corporations, individuals, and others, civil society. Why should you care about that? Because who is doing the governing and who is affected by the instrument then affects the type of governance and the type of objective. So you wouldn't have a treaty to govern the way that states interact with individuals per se. Well, maybe you would, but generally you wouldn't, because treaties are between states. Then we talk about the instruments. Do you pass laws, policies, types of risk again? Do you roll out your classical actuarial risk approaches? I mean, we have ways of dealing with black box risk already. You can take a bet on whether a cyclone is going to hit some part of the world. It's effectively a bet on a black box. We have tools already. So again, what changes when we deal with quantum computing? I should say, what's really important with governance is how the technical standards develop. So IEEE, which is an engineers association, has a significant influence, for example, on how technology is developed. So, understanding how the technical standards will be developed and are being developed right now by IEEE is key if you're interested in quantum governance. I think I've got 2 minutes. Legal implications. I know people here have written already on this, but we want to sort of understand what implications are for intellectual property law, which I know Mark has written on. Competition law. Quantum is big science. You're not going to have one in your backpack, in spite of what some people say. So this is concentrated wealth and power. How does that affect who gets to access quantum? Human rights and quantum technologies, and we've heard on healthcare. Matteo spoke earlier about the use of empirical methods. I think that's key across all tech governance. So there'll be a chapter on this. How do you deploy empirical methods? And things like quantum impact assessments. There'll be a chapter on social science techniques, so this is quite important. You want to co-design technology, as you evolve. You don't just want someone to build an oracle and then say, here it is, everyone, because that can generally lead to bad outcomes. But equally, you don't want too many chefs spoiling the broth, so to speak. So not everyone gets a say at every point in the governance structure. The economics of quantum as well is something which is interesting. Some people have started to write on this. There's also a lot of interesting stuff. I mean, I like it in terms of quantum game theory. So as different countries build quantum computers, how does that impact how they interact? So I find that personally fascinating. What types of economic policies would promote quantum computing? Would someone having a quantum computer lead to economic instability? I.e., if someone can win the game all the time, it's not good for all the other players. So that's something one needs to consider when you're building these types of technologies. We've had a bit of defense and national security, and I think I'll leave it there because I think I'm out of time, but thank you. Oh, please, sorry. If anyone would like to contribute, please reach out to me or the team here. Thank you.
Thank you so much, Elija. I'm extremely excited about your project and the handbook. The next segment is about the Holland Innovation Network and focuses on the efforts of the Netherlands in quantum technology. Tyrone Pater.
Took the non-traditional route to get on stage. Thank you, Maurits. Thank you for putting this conference together, and it's great to see all the work of the center. Thank you for having me. And on a personal note, it was great to be here when the center was launched in the presence of our Prime Minister, Mark Rutte. Maybe as a brief personal introduction, I'm not a quantum expert. I'm also not a lawyer, not even a scientist or a scholar for that matter. So therefore, I must represent the government, which I do. I work for the Netherlands government, and I'm based here in San Francisco. What I will be talking about today is... You'll need to be on. What I will be talking about today is I will share a little bit more about my work and the government organization that I represent, the Netherlands Innovation Network. Not allowed to say Holland anymore, unfortunately, Maurits. And maybe provide a bird's eye view on how the Netherlands looks at quantum, where are we investing, what are our ambitions, what is our focus, and then maybe also a little bit about responsible quantum innovation. Let's see if this... So the Netherlands Innovation Network is a small and focused network. We're the foreign division of our Ministry of Economic Affairs. And represented in about 23 offices around the world, all in places where the local economy is mostly driven by innovation and technological output. Our mandate is very simple and extremely complex at the same time. We need to think about the future competitiveness of the Netherlands economy. So what are we good at now in terms of critical and emerging technologies? What do we make our money with now? And what will we make it with in the future? Now, how do we do that? One side of that work is very practical. We look at technological areas where the Netherlands is good. Think semiconductors with ASML is the most famous example probably, but also things like photonics, AI, and yes, quantum. And think practically about what that means for example, for me here in Silicon Valley. Which partnerships do we need to establish? How do we help our companies find investment? How do we help researchers find like-minded researchers in the US or on the west coast of the US? And I will say that is the fun part of that work. Part of that is organizing large missions, organizing delegations, putting on events and panels and conferences much like this one. And part of that work, and increasingly, I must say, is much more about research security, about economic security, about changing geopolitical situations, about technological competition between countries. And that's something that I have, over my time here in the US, seen change over the last 3 years. And that also means that sort of the core of the work is changing. And that finds it... that makes it much harder in some cases to think about what we do in quantum, for example. Now, to provide a very simple and brief overview of our quantum ambitions in the Netherlands, I've chosen sort of three things that I will talk about. One is our national technology strategy that we published earlier this year. Then our investment vehicle, the National Growth Fund, which we can use to stimulate some of these technology areas. And then I will talk a little bit more about other public investments and international collaboration and why that is important. Now, by 2035, the Netherlands will have a world-class quantum ecosystem for business and research, and will be a magnet for international talent and a positive contributor to the global value chain. Another way that you could read that last part is we will have control points in the global value chain for our own economic security. Now, this is not something that I made up. I took this directly from our national security strategy. I did translate it myself. I didn't have ChatGPT do that. But these are quite lofty ambitions for a small country like the Netherlands. Only 18 million inhabitants. Yeah, this is something that we want to achieve. And we've been investing in quantum for quite a bit. And we've sort of elaborated on what we will do until 2035 to achieve these ambitions in our national technology strategy. It's a strategy that is that we co-collaborated and created with civil society, private sector, academia, experts in technology areas that are important for us, and that we think we are well positioned to capitalize on going forward. One of those technologies is indeed quantum. The other ones, there's 10 in total, can be quite easily guessed. It's things like cybersecurity, like AI, like semiconductors, like photonics. And I don't think I have to tell this audience that all of those things sort of interlink as well. Now, saying that we are ambitious and actually achieving the goals are two different things. So we are facing a lot of challenges around quantum in terms of, for example, talent, how to retain the talent, how to educate the talent, and how to also import talent, to be honest. And then we are also thinking about things like dependencies on critical raw materials, like we've heard about earlier today. And basically, a short way of saying this long story is that we came to the conclusion that we need to invest. We've already been doing that for a long time in the Netherlands. I think the most famous example is in 2021 when we committed a total investment of $675 million to invest in quantum research, to attract talent, to develop a scale-up technology, and to create a thriving ecosystem with critical mass. Created an organization that is responsible for the budget and to create that ecosystem, and I think that's probably well known in this group. It's Quantum Delta, the Netherlands. And they are operating through 5 hubs in the Netherlands, working with private sector, with academia, to drive innovation forward. And at the same time, they're also the bridge between civil society and the government. Because I think another conclusion of today is that one of the conclusions is that government does not always have the knowledge to effectively regulate, for example, or figure these problems and challenges out by themselves. Now, in terms of other public investments and international collaboration, this is something that we're still figuring out, and I'm actually looking for input from this group as well, so find me afterwards. If you have more ideas than I've already heard today about how nation states should collaborate together to really create a thriving quantum ecosystem. Within the EU, we're already doing this with Germany, with France. We signed a trilateral agreement just last year with funding from the 3 governments, and we are also contributing to many EU initiatives, as well as pursuing bilateral agreements with, for example, the US. Let me quickly talk about focus. Now we'll sort of glance over this, but on the left side, is the Quantum Delta Netherlands sort of visualization of what they're focusing on. And it's perfectly aligned with our national technology strategy. So we cannot focus on everything. So therefore, we choose to invest in quantum computing and simulation, national quantum networks, communications, and quantum sensing. Now, we did not come up with this ourselves. So this is really the result of roundtable discussions with experts in the Netherlands. Where are we? Where is our research ecosystem? What kind of applications do we see? And are we investing in the right things? Then if you go to the action lines that are sort of programs around research and innovation, around creating a critical mass for an ecosystem, around human capital, and I think this is the first time that I'm mentioning it, societal impact. On the right side, that's more about links to other key technology areas. How do they interact? How do they interplay? And maybe I'll just let you read that yourself, but maybe it's funny or interesting to note that when I was reading through our national technology strategy, for many of the other sectors like cybersecurity, like semiconductors, besides a visualization that shows links to other key technology areas, there are also very clear links to application areas and use cases. And that's something that I could not discover for quantum technology yet. So it's something that we're still very much thinking about. And then just to wrap it up, thinking about responsible quantum innovation, I've not talked about that a lot. And that's because that conversation is not really top of mind within our government at the moment. So if I look at the initiatives in the Netherlands, they're mostly driven by universities, ecosystem organizations like Quantum Delta, the Netherlands AI Coalition, and they're doing great work. But the work that they're doing does not always reach back to government. If I think about government specifically, we say that in the Netherlands our mission or our goal is to pursue a mission-driven innovation policy, which means that the technological developments should serve society as a whole and basically be used for good, ethical, all the things that we've already talked about today. Now, a challenge that I face, to make it personal, if I go back, let's say I see a quantum use case or a technological breakthrough here in Silicon Valley, and I see a use case for the defense industry or the medical sector. I know exactly who to approach in the Netherlands within the government to say, here is a chance, here we should capitalize, maybe there is something in it for us. Now, if I'm worried about those same use cases, I would have no clue where to start within my government. And therefore, I think I will leave you with this. I believe that governments need to continuously interact with other governments, private sector, academia, and civil society to ensure that technology developments serve society. And there's no one actor that can go this alone. And therefore, conferences like today, Maurits, what you've put together, I think are crucial to bring all stakeholders together. Thank you. Exactly on time.
Thank you so much, Tyrone, for your informative talk, and a shout out to your colleague Walter de Wit, who couldn't make it today, but who will certainly watch the video. Now we have a message from the European Commission by Dr. Gustav Kalbe, and after that we will have a short networking break with musical interludes. So.
Hello, I'm Gustav Kalbe. I'm Director in the European Commission, responsible for the definition and implementation of the quantum policy within the Commission. It's a great pleasure that I've been invited to present you in a small talk what we are doing in the European Commission with regards to responsible technology in quantum. But before I explain to you what measures we're putting in place to make sure that quantum technologies are used in a safe, ethical, and trustworthy way, let me first explain the main lines, what we're doing here in the European Commission to foster quantum technologies, with what purpose we're doing it, what are the risks we have identified related to the use of quantum technologies, and what mitigation measures we are putting in place. Now, Europe has been since more than a century a place where quantum physics was always a stronghold, and we have seen that in the last decades, this excellence we had, and partially also due to the massive public investments that were made from the European Union, but also in conjunction with the European member states, that we now have gone to a next stage where it's no longer about quantum physics, but we really see the first tangible products, the first tangible equipment coming out from quantum that find slowly but surely their way into our daily lives. We have been covering from fundamental science up to the deployment of the infrastructure, making the different quantum technologies tangible and accessible to users, to a wider community that is not specialist, that is not the quantum physics community. We have, in the last few years, embarked in a number of infrastructure programs precisely to make the quantum devices, the quantum technology, something that can be experienced by the normal citizen, by the industry, by the public sector, by anyone that is interested, that is not coming from the field. And we have deployed this infrastructure for a number of reasons. One, of course, is putting quantum technologies in a real environment, putting them to the test of daily life, to accelerate the maturation, but also to understand much better how it is applied, under which condition does it make sense, where does it make a difference with respect to the traditional approaches, be it in sensing, be it in computing, be it in communication, or any other digital application. Equally important is our motivation to now help the emergence of a market, of an industry for quantum technologies. And this in two ways. One, of course, is by investing in the results of our research programs, by buying and deploying these quantum devices in infrastructures, notably for quantum computing or for quantum communication, and now even for quantum sensing. We create a lead market and help our creators, our inventors, our startups to have a first user market where they can showcase their products and together with the users accelerate the maturation of the products. But equally, it's for us a very good opportunity to show the potential, the capacities of quantum technologies to a very large user base that will understand what quantum can do and hopefully embrace it and include it in their products or business processes. So with this deployment of the infrastructure, we are hoping that in a couple of years from now, quantum will become commonplace as more and more users and more application domains are embracing these new technologies. Now, of course, we're not just doing this in order to create an industry to establish markets, but because it's our profound belief that quantum technologies have a transformative character for our society, for the well-being of our citizens, bringing huge advantages in a number of domains from health, energy, environment, safety, security, etc. You just name it. And we are really here to make this transition happen. And I will give you now some examples where really quantum will have an immediate and measurable benefit to our citizens, but also to a number of everyday applications. Let me start with an example from the health sector, from medicine. With quantum sensors, we will be able to measure the metabolic processes at the single cell level to have a much more accurate, much faster possibility of diagnosing health issues like brain cancer or other types of cancer in the body that will facilitate and accelerate the treatment and have a much more precise diagnosis. We also have, with the quantum computers, very good potential to accelerate and take advantage of this huge evolution we now have in artificial intelligence, where quantum computers are seen as one of the key tools for machine learning, deep learning, for facilitating the development and training of the AI models to overcome current limitations of classical supercomputers. We do not know yet all the applications for quantum computing and where they will make the breakthrough, but this is an example where we are confident that due to the highly parallel character of quantum computing, this will make a major difference to fuel the further development of AI models and their usage, and this at a much higher speed than we can do now, with higher precision and take into account much larger data sets. The last example I would like to give is on communications. With quantum communications, using quantum physics to encode our keys or to encode our messages, we can make security future-proof, make sure that even with advances in technology, the communication of data will stay safe and protected, but also data, once it's stored, will remain secure and safe even for the next decades to come, because there's no way to break the cryptography. And that's where we're now coming to the other side of the medal, the risks of quantum technologies. I mean, we're fully aware that quantum, like any other technology, can be misused. It is potentially dual use. It can be put in place for criminal activities. Technology can be abused. The most evident example, of course, is using quantum computers to break traditional encryption schemes. The Shor algorithms may be the best known and oldest quantum computing algorithms, and the danger that is posed by quantum computers on the classical technology, we will need to address it either by moving for more robust crypto algorithms, the so-called post-quantum crypto algorithms, or by using here again quantum and quantum communication links to protect our information, our data, our communication against attacks even from quantum computers and make them inherently safe in the long run. We also know when we're using the quantum sensors I mentioned in my example before for health applications, there's a huge risk of misuse of data, of leakage of the most private data that we can imagine from a human being. Here again, we'll have to find some mitigation measures. Quantum computers, we can, as I said, use them to break cryptography. We can also use them for a lot of other applications that are not ethical or are banned. But the point I want to come here, and that will be my concluding remarks, we have to see quantum as a technology, as a tool that is enabling a wide variety of activities that are to the best of mankind. I hope the examples I've given you have convinced you to what extent quantum will really have a breakthrough character and make a massive step forward towards our well-being, our health, our safety, etc. And on technical level, we might have a certain number of safeguards or ways to protect, like post-quantum crypto or quantum communication. But the key point here is that in this respect, quantum is not different than many other digital technologies that are just a tool, that are a vehicle to achieve an application. And that's where the safeguards are and will come for a responsible use of the quantum technologies. I can give you some examples. Let's go back to the example of quantum computers to train and develop artificial intelligence models and applications. We have just in the European Union adopted the first region worldwide, the AI Act, that gives the conditions and regulation how in Europe you have to use AI in an ethical, trustworthy, and safe way, independent of how you calculate the AI, on which machines are running, if it's quantum or high-performance computing or on the cloud. Likewise, for the example I gave on the medical side, there is a very extensive, very precise legislation in place already, how private data is to be used, give access, stored, and even on top of that, a specific regulation on the health data. So you will see that we have for the use cases we know today on quantum technologies, we have spent the last 5 years, the time of the current Commission, to make sure that our digital legislation is in place to protect the users, to make the society safe from abuse, all the risks of digital technologies, but putting the legislation at the right place and not trying to legiferate everywhere. With this, I would like to conclude my talk by thanking you for having given me the opportunity to shed some light on the European approach to quantum technologies.
Thank you so much, Dr. Kalbe, for your inspiring words. We now have a short coffee break, and I'll see you back in 10 minutes. Thank you so much.